All right. So question number 2. This one involves experimental probability. It says, of the last 12 contestants on a game show, 9 qualified for the next round. What is the experimental probability that the next contestant will qualify for the next round? So there's no theoretical probability here. There's nothing about like flipping a coin or rolling dice, something like that, where you know kind of what the probability is going to be based on the number of sides that something has. This is based purely on data, and the data says that 9 of the last 12 qualified for the next round. So our experimental probability, if we were to think of this as a big fraction, okay, this would be looking at 9 out of 12, okay? Now, it says type your result in the empty box provided below in simplest fraction form. So again, my fraction is 9/12. So if I wanted to write that in simplest form, okay, there's some calculators you could use to do this, but this one's pretty straightforward. It looks like 3 is the greatest common factor of 9 and 12, and 3 goes into 9 3 times, and it goes into 12 4 times. Okay, so 9/12 reduces to 3/4. So I'll go over here in the box. I'd use the fraction, which is, looks like they only give us one of the fraction things. Oh well, we'll use that one, and we type in 3/4. Okay, and that would be the experimental probability of the contestant qualifying for the next round, based on what was the previous data that we have. Okay. All right, I'm going to move on to number 4. A coin and dice are tossed at the same time. Select the list that shows the possible outcomes. So remember, this is called our sample space. A list of possible outcomes is the sample space. Now, in this case, when you throw a coin and dice, you basically got 2 things, okay? 2 possible things happening. Now, I could, like this number 1 list, it looks intriguing because it shows heads, tails, 1, 2, 3, 4, 5, 6. But I want to know the possible combinations of these things happening too. Okay. So if I get heads, I could have heads and 1, heads and 2, heads and 3. It looks like C best represents the different ways that they could land. Okay. These first 6 involve heads with all the different numbers of the die, and the second 6 here involve tails. Okay. Now, the question is for B is find the probability of getting a head on the coin and a 6 on dice. Well, nice thing is we have our sample space listed out here. We know there's 12 items total, right? And only one of them is their head and 6. So it looks like we'd have a 1 in 12 chance of this happening. Okay. Again, now this is asking us to write as a fraction. So I can go down here, and I can put this fraction in. Okay, now they give you the fraction button here that has like a space in front and a fraction. You can just push the arrow key to the right to get into the fraction. And we said it was 1/12. Okay. 1 in 12 chance. And you could just figure that out right from here. Now we could have done it using our, like we've been working, where we have our 2 spaces. We'd have 2 dashes here, and we'd say, well, there's a 1/2 chance of getting heads, and there's a 1 in 6 chance of getting a 6. Multiply the 1s across, you get 1. Multiply the 2 times the 6, and you get 12. So we could have done it that way as well. Okay, but it's nice having the sample space laid out for us right here. Okay, I'm going to skip down to number 9. An automobile dealer has cars available with the combinations of colors, engines, and transmissions indicated in the following tree diagram. A selection is made at random. So they're picking a car at random that could have any of these three things. Okay. Or sorry, any of either red or blue, 4-cylinder, 6-cylinder, and manual or automatic. What's the probability of selecting a blue car with a 4-cylinder engine and a manual transmission? Okay. A blue car. So it's going to be from this group, 4 cylinders with a manual transmission. Well, looks like that there's one car that has those three things. Okay. And it's one out of 1, 2, 3, 4, 5, 6, 7, 8. 1 out of 8. So now they're giving us a decimal. So if I don't know what 1/8 is off the top of my head in a calculator, I can do 1 divided by 8 and I get 0.125. Okay. So you'd have a 1 in 8 chance or a 0.125 probability of picking this selection if you're picking at random. Okay. All right. Number 10. Another tree diagram. Use the tree diagram and assuming that all options are equally likely, what is the probability of using sprinkles? Well, let's see, our probability, you can pick vanilla, strawberry, or chocolate, and then you get nuts or sprinkles. So it looks like sprinkles shows up 1, 2, 3 times out of the possible 1, 2, 3, 4, 5, 6 times. Well, 3 out of 6, that's half. Okay. There you go. There's our equivalent fraction, 1/2. And I know most of you probably got these right, but I'm just making sure we understand them moving on. Number 11. Which tree diagram shows all of the possible outcomes for tossing a coin and rolling a fair number pyramid that has 4 sides labeled 1 through 4? Okay. So we need the one where we get heads or tails because that's throwing a coin, flipping a coin. Okay. So we need heads or tails. So looks like B, C, and D all include flipping the coin, heads or tails, heads or tails. And then the pyramid has 4 sides. Okay. So we need one that has 4. Heads, tails. Good. And then we need all 4 sides. 1, 2, 3, 4. Well, it looks like these two look very similar, but if you look closer, C says 1, 1, 2, 2, 3, 3, 4, 4. Well, that's not going to happen because you could do tails and 1 or tails and 2. So it looks like D is going to be the correct answer here. Okay. Number 12. A bag contains 3 red marbles, 4 blue marbles, and 5 yellow marbles. In this experiment from the bag, you select a marble, record it, and place it back into the bag. You then select a second marble. What is the probability that you draw 2 blue marbles? Okay. All right. Well, here's one where we've got 2 events happening. 1 marble pick, and then a second marble pick. And in both cases, you're going to have these marbles in the bag because even after you pick the first one, you put it back in the bag. So you have 3 red, 4 blue, and 5 yellow. Well, what's the probability you draw 2 blue marbles? Well, let's figure out what the probability of getting a blue marble on the first try is. Okay. Well, that would be you have 4 marbles out of, let's see, 3 plus 4 is 7. 7 plus 5 is 12. You'd have 4 out of 12. And we put it back in, so you'd have another 4 out of 12 chance. Okay. Now, we could leave the fractions like this, okay, and multiply, and we would get 16 over 144. All right. Now, this will be a lot easier, though, if we use our smaller reduced fractions. So 4/12 is the same thing as 1/3. And we could do 1/3 times 1/3 and get 1/9. Okay. Now 16 over 144, those are equal. Okay. Those are equal. And if you have a calculator that helps you reduce fractions, you could do that. To be honest, off the top of my head, I probably wouldn't know that 16 over 144 equals 1/9. So I'd probably start reducing this by cutting everything in half. I'll say, all right, well, I know half of 16 is 8, half of 144 is 72, and I still am maybe not sure. And all right, half of 8 is 4, half of 72 is 36. And once I get here, I'm like, all right, I think 4 goes into both these, and I could probably get to 1/9. Whatever's going to be easiest for you to reduce this, or if you want to reduce at the beginning and get 1/9, that's probably the most straightforward way of doing this because it's going to give you a simplified answer to start. And looks like we do see a 1/9 answer right there as B. Okay. Number 13. Jeremy will roll a number cube. Let me make sure there's nobody else waiting for us here. Bear with me just a second. All right. Jeremy will roll a number cube numbered 1 through 6 twice. What is the probability of rolling an even number than the number 3? Okay, so two events here. So I'm going to put my two blanks here. So let's see, probability of rolling an even number. Let's figure that out first. So probability of rolling an even number. So our sample space will be 1, 2, 3, 4, 5, 6. There's 1, 2, 3 of 6. So that's half of them. So half the numbers are even. And the number 3, well, there's only 1 3 out of 6. So that'd be a 1 in 6. If we multiply these together, 1 times 1 is 1. 2 times 6 is 12. So there'd be a 1/12 chance of getting an even number and then rolling a 3. 1/12. Okay. 16. The following table shows the number of goals that the Texas Sharpshooters score on each of their 8 hockey games this season. So 3, 4, 1, 4, all of these are their number that they scored. Based on this data, what's the probability that the Texas Sharpshooters score exactly 1 goal? Well, it looks like in 1, 2, 3, 4 of their 8 games, they scored 1 goal. That's half. And if we want that as a percentage, half is 50. 50% of the time is the same thing as 1/2. Okay, so converting those percentages, a lot of times you can do that. It's easier to do from a decimal. So like 1/2 is equal to 0.5 as a decimal because 1 divided by 2 is 0.5. And then to get your percentage, you would move this 2 places. So the decimal would move over here, and that would give us a 0 right there, become 50%. Okay. All right. Number 17. Nadine draws 1 color cube at a time from a bag. She records the color cube before returning the cube to the bag. The table below shows her results. Match the event on the left with the experimental probability of the event taking place. So the probability of getting red, okay, probability of getting red was 3. Well, we need to know the total number of times that were drawn. 3 plus 4 is 7. 7 plus 5 is 12. So 3 out of 12, which is 1/4, would be red. Yellow would be 4 out of 12, or 1/3. And blue would be 5 out of 12. Okay, pretty straightforward there. All right, number 18. This one's very similar, almost an identical type problem. So I'm going to go ahead and move on to number 19. Again, another very similar one, just using the X's instead of the slashes. I think we're pretty good on the probability of a fair coin, what we're going to get. You got a 0.5 chance of landing on heads or tails, in this case, tails. So similar, we just have data here. Probability of ordering shrimp skillet. Well, there were 5 shrimp skillets ordered. You just need to know the 5 out of the total number and use division to get your answer. In this case, it'd be 3 plus 6 is 9, plus 2 is 11, plus 2 is 13, plus 5 is 18. So it'd be 5 out of 18, which is 0.277, or rounds to 0.28. And just a couple more here. Probability of an event can be greater than 1. That's false. Events probability has to be between 0 and 1. 0 being it has no chance of happening, 1 meaning it's certain to happen. There's another one where we've got Tom reads 20 books, 12 magazines, 18 newspaper. They want to know what the data, based on the data, what percentage Tom reads a newspaper is, reads a magazine. So we take the number of magazines, 12, out of the total number of things that Tom is reading. They want to know percentage-wise what it's going to be. So let's look at this one real quick. It's very similar to what we just did a couple slides ago. But this one's going to be, you start off with 12 magazines out of the total number. See, 20 plus 12 is 32. 32 plus 18 is 50. Okay. Now I could try and figure out what this fraction is equivalent to out of 100, because this is the same thing as a percent, and 50 times 2 is 100, so 12 times 2 would be 24. So my answer would be 24%. Okay. Or I could do 12 divided by 50, and it would give me 0.24, and 0.24 written as a percent is 24%. Okay.